In this problem, we're told to find the limit as x approaches infinity of one polynomial over another. And as x gets really large, all of the lower power terms in the numerator and the lower power terms in the denominator become insignificant compared to the highest power term. And so this 3x squared and the 4x and the 2 and also the lower power terms down below become insignificant compared to the 2x cubed and the 4x cubed. So this reduces to 2x cubed over 4x cubed, which can then simplify. The x cubed on the numerator and denominator cancels, and we're left with 2 over 4, which is equal to 1/2. And that's the answer. Now, to understand why that works, just imagine x getting really, really big. And so if you were actually evaluating this function, you'd be plugging in numbers for x in the numerator and plugging in numbers for x in the denominator and doing those calculations independently. The numerator calculated independently from the denominator. And as x gets really big, all of these terms that contain an x start to get really large. But the higher power term, the x cubed, becomes larger much faster than the lower power terms. So as x approaches infinity, or what we really say, as x grows without bound, all of the lower power terms in the numerator become insignificant compared to the highest power term in the numerator, and the same thing with the denominator. All of the lower power terms can be ignored for extremely large values of x. So the function, the closer we get to infinity, or really the larger x gets, the more closely the function approximates the expression obtained just from looking at the lead terms, the lead term of the numerator and of the denominator. So we just make a new rational function from those two lead terms, and in many cases that will simplify, and in this case it simplifies down to 1/2. So this function, if graphed, would have a horizontal asymptote at y equals 1/2. And this technique of finding the horizontal asymptote, or finding the limit as x grows without bound, this works for rational functions whenever you have one polynomial divided by another.